Hi, this is James Cook, Assistant Professor of Social Science at the University of Maine at Augusta, and this video has been recorded for our undergraduate social networks course. Today we're going to think about two-mode networks, how they relate to one-mode networks, what the difference is between those two modes, how to move from one mode to another in theory, and then how to move from one mode to another in practice with some real-world, consequential, political network data. Let's get started. So, what is the distinction between a one-mode and a two-mode network? Well, the word mode might make you feel a bit of panic, like this is a highly technical term, but it really isn't. A mode is just a kind of an object in a network. So one-mode networks have one kind of object. Two-mode networks have two kinds of objects. That's the only distinction between the two of them. It's simple, just like a social network is simple. So when we think about one-mode information in a network, we're thinking about ties between nodes. There's just one kind of object in that network, nodes, and their relationship to one another. A two-mode kind of information in a network involves just a little bit more complexity, just two kinds of objects. Now we have nodes and the things nodes belong to, the things they're affiliated with, the memberships that those nodes have in events, participating in events, in organizations, being members of organizations, or actions, taking part in an action. Those events, those organizations, those actions, groups you might call them, going to a play, having seen a movie, having voted in an election. Those are all affiliations that nodes can have to larger objects than them. It connects, if you want to think about it from a larger point of view for a moment, it connects the micro-social aspect of a social network to the mesosocial, that is not completely big, but a lot bigger, the mesosocial world of groups, organizations, institutions, and activities that make up the interesting bits of a society. That's the only difference between one-mode and two-mode networks. Okay, it's just kinds of objects there are. How many? One or two? So, if we're thinking about a network, one way to represent a network is by a matrix. If you're not familiar with matrix, I suggest that you take a look at our course textbook. If you're not a student of mine, I suggest looking at some of my other videos to think about the distinction between a matrix and a network graph. One of the ways to represent a network is through a matrix. And a two-mode matrix is called an affiliation matrix. Why? Because you have two kinds of objects, and one of them is a node and the other is the affiliation of the node with an event or an organization, a group, something like that. That's why it's called an affiliation matrix. And if you have two kinds of objects, how would you represent that in a matrix? By moving away from the one-mode convention of a matrix, which says, oh, the rows and the columns are the same, and we're looking at the relationship between two nodes. No, we're not looking at that anymore. In a two-mode matrix, the rows and the columns are different. So now here, the rows may be people, they may be the nodes, and in this case, we have 4 columns, and each column is what? A student organization at a university. Those student organizations might be student government, the tennis team, the college Republican club, and Campus Crusade for Christ. This is completely made up information, okay? But go with me here. So sometimes it's good to start with a hypothetical example. So if the rows and the columns are different, well, what do these ones and zeros mean now? It's not about relationships between nodes. It is whether or not a node is affiliated with a student organization. So let's get very explicit here. Alice, if you take a look at the row for Alice and you run across, you'll notice that there's a 1 for Alice and student government. That means Alice is a member of the student government. There's a 0 for Alice and the tennis team. Alice hates tennis. She's never really been into it, and she wouldn't join that stinking team anyway, right? There is a 1 for Alice and the college GOP, and a 1 for Alice and Campus Crusade for Christ. So we know Alice is a member of the student government. She is a member of the college GOP. She is affiliated with the Campus Crusade for Christ, but not the tennis team. Well, we could do that same report for not just Alice, but for Ben, for Carl, for Deb, for Eric, for Flo, and for Glenda. And notice there's a lot of information to report. It took me a minute or two just to talk about Alice. And heck, there's 7 times as much information because there are 7 nodes here. And yet it's a nice compact package. Here we have membership data for 7 whole students in 4 organizations. The 2-mode matrix, the affiliation matrix, is our way of doing that. To give one more example, just in case you need a little cementing, let's think about Deb. Take a look at Deb for a moment. Can you figure out on your own, pause the video, what groups Deb is a member of? Okay, so you should have been able to figure that out. Deb is a member of the college GOP and also of the Campus Crusade for Christ, but is not a member of the student government or the tennis team. One more challenge for you. There's more information you can get from this matrix. How many people are in student government? Do you see it? Add up the ones going down the column for student gov. 4. There are 4 people in the student government. Alice, Carl, Eric, and Glenda. Adds up to 4. There are 4 people. We could go add across. How many student organizations is Ben involved in? How many is he affiliated with? How many is he a member of? 1. Only the tennis team and none of the others. And we can see that by adding across. So this is a mathematical object, okay? And when I say mathematical, it doesn't have to mean hard. The math of this is pretty easy. If you can add ones all together, you can do this, which makes it a very powerful object. The most powerful mathematical objects, I think, are the simplest ones, the ones that everyone can see and understand, but that represent an important idea. I get excited about this. And the reason I get really excited about this is because Ron Breiger, in 1974, Social Forces, the Duality of Persons and Groups, wrote an article that we discuss elsewhere in our class lecture that talks about taking this 2-mode information and thinking about it. And thinking about it to make 1-mode networks from the 2-mode data. Let's talk about that concretely, okay, using this example. Up on top, we have a 2-mode affiliation matrix. How do you know it's our 2-mode affiliation matrix? Well, partly because it looks pretty familiar. It's from our last slide. But also you can look and you can say, are the rows the same as the columns? No. They're not even the same kind of things. One is a social object. What kind? A group. What is the other kind? People. Oh, the nodes in a network. 2 kinds, 2 modes. But at the bottom, check it out. There is a 1-mode adjacency matrix. Whoa. How do I know it's one mode? Well, first key is that everyone in every row and every column that's labeled is a person, and they're the same people. So this seems to be your classic social network adjacency matrix. Who is adjacent to whom? Who is tied to whom? However, the data in it are a little unusual. Let's look at those. Look at those cells. They're not ones and zeros, indicating the presence or the absence of a tie. There are zeros, yes, but there are ones, but there are also twos and threes. Whoa, okay. So what does that mean? It means that some ties are stronger than others. And what do those numbers mean? Well, let's go through a few examples. Because what that adjacency matrix at the bottom is the transformation of the two-mode affiliation matrix at the top, going from top to bottom. What does that bottom matrix represent? It represents the overlap in groups. How many groups does one node share with another? How many memberships does one node share with another? How many affiliations does one node share with another? Let's go through a few examples and think about how we would move from top to bottom. Well, one thing we can do is we can think about the diagonal of this network. What is a diagonal? It is a node's association with itself. How many groups does a node share with itself? Well, the number of groups that the node is a member of. So let's take a look at the top matrix. Alice is in the student government, the college GOP, and the campus Crusade for Christ, right? She's in 3 groups. She shares 3 groups with herself. Oh, okay. That's just a complicated way of saying she's in 3 groups. So notice she has a 3. Notice Ben in the diagonal, right? The diagonal is the set of cells that in which a node is referring to itself. So going from Alice to Alice and then Ben to Ben, we see a 1. What does that mean? Oh, Ben is only a member of one group. Remember the tennis team? We can see that up top. If you need to follow through, go back, rewind, or pause the video, and you can see that for yourself. Looking up at the top, there's a 1 only for Ben in the tennis team. So Ben shares 1 group with himself. Oh, this is pretty straightforward. What about Carl? Carl shares 2 groups with himself? Yes, the student government and the tennis team. And so you could go on and on. Deb is a member of 2 groups, so she shares 2 affiliations with herself. Eric, the same, member of 2 groups, 2 affiliations with himself. Flo is only a member of 1 group, like Ben. She's only on the tennis team, so she only shares 1 with herself. And Glenda shares 3 with herself because she is, like Alice, a big joiner. She's joined 3 student organizations. In fact, the same 3 that Alice has joined. Okay, so what does that mean? It means that we understand the diagonal. It tells us something useful. It tells us who is a member of more organizations. But now let's go off the diagonal from Alice to Ben. How many groups, how many affiliations do Alice and Ben share? None. That's because while Alice is a pretty big joiner, she's a member of the student government, the college GOP, and the campus Crusade for Christ, the one group she hasn't joined because she hates tennis is the tennis team. She's not on the tennis team. There's a 0 there for her. But that's the one group that Ben has joined. So there's a 0 there. And in the bottom matrix, right? Alice and Ben share no groups. Now, if you're a student in my class, you just finished some homework in which you talked about the contexts in which you met people, right? What are those contexts? You're a coworker, you're in the same family, that's like a group, isn't it? Or maybe there's a you're on the same campus with at the university, or you're a member of a club, a student organization perhaps. So you might live in the same town. A town is like a club that you can belong to. You can be a resident of it. You're a member of that town. If you don't share any town or any group membership or any university student membership with someone, how likely are you to get to know that person? To bump into them. You're not going to bump into them because people meet each other in groups. This is Ron Breyger's point in that 1974 article, The Duality of Persons and Groups. So when we say Alice and Ben have a tie of value 0, it means something. The 0 means they have no group memberships together, and it also means that we predict that they are going to have a very weak tie. In fact, so weak that we know of no context in which they would meet each other. It's very unlikely that they are going to share a friendship with each other, that they are going to share needles with each other, that they're going to share diseases with each other, cough on each other. If we're thinking about an epidemic network, right? So these things matter. Who's going to spread diseases to whom? Our bottom matrix might tell us. Alice and Carl might be a little bit more likely to form some kind of connection. Why? Because they are Alice to Carl or Carl to Alice. It's going to be symmetric, you'll notice. They're members of one group together. Which group is that? The student government. If they're members of the student government together, that means that they have to listen to the same interminable reports every Friday when the student government gets together. It means they hang up signs together. It means they're doing things together that student government members do. That's great. So that's a chance for them to get really involved. But hang on. Are Alice and Carl going to be best buds? Well, maybe not, because take a look at Alice and Deb. Now, Alice and Deb, right, if we take a look at the top matrix, the affiliation matrix, the two-mode matrix, excuse me, if we look at that two-mode matrix, we can see that Alice and Deb are members of two groups together, the college GOP and the campus Crusade for Christ. Now there's two sets of meetings that they sit together on. That's two sets of late night banner hanging for some kind of activity on campus. That's two kinds of t-shirts that they share, and they have to wear the same kinds of t-shirts because they're members of the same group. That's twice the amount of opportunity for them to form a friendship. Now, Alice and Deb are really close, and Alice and Eric we would expect to be sort of close too. They also share two groups, but Alice and Glenda, they share each of their group memberships with one another. They actually have the strongest connection in all of the network. They have the largest number of groups shared with one another. Who are the best buds going to be in this network? If we had to guess, Alice and Glenda. Even if they're enemies, they're going to have to be frenemies because they're going to have to interact with one another. They're doing so much together. They certainly are going to know about each other, and they probably have a lot of interaction with one another too. We can find this out just by getting membership lists. Wow, okay? Think about that for a minute. If you are a student in my class, you've been engaging in work to go out and collect network data. You know how hard that is, right? To go from one to another, one to another, one to another, just for your own ego networks. Now imagine describing the number of relations between 7 people. You know from the math earlier that we're talking about 7 times 6 or 42 divided by 2 people if you're talking about symmetric relations, which is 21 possible relations that you'd have to collect. Okay, 21. That's a lot of information to grab. You have to go out and talk to all these people about 21 relations, or you could just go get 4 membership lists. 21 or 4? Which one's easier? Two-mode affiliation data is invaluable because it really does give us a glimpse about into who is being shoved together with whom, who is likely to form a tie with whom, but it's really easy data to get. It's easy information to get. Okay. Now, you could go through, and I encourage you to pause this video and think about a few more examples. Let's think about Eric and Deb. Okay. Pause the video. Tell me how many groups Eric and Deb are joint members of, what group that is, what groups that they are, and what their tie strength is. Okay, pause. Okay, so you know we had Eric and Deb. Eric and Deb are in one group together, the college GOP, the College Republican Club. So they have a tie strength of 1. Okay, and that is better than 0, but it's not 3. So they're moderately tied to one another, we might say. Okay, if I was selling you Ginsu knives, I would say, but wait, there's more, because there is more. How much more? Well, there's twice as much, because we cannot just talk about connections from student to student. Person to person. We can flip the whole operation around and talk about connections between groups. What I mean is this. If groups connect people together, people connect groups together. Think about it this way. Let's imagine the college GOP is having a little bit of a crisis. Somebody is challenging the bylaws, you know, which happens if you're in a college GOP group or any college political group. Somebody's going to say, order, I challenge the bylaws. I say we need to change the bylaws and kick out the current president. And all of a sudden everybody in the club is saying, what do we do? What do you mean kick out the president? Is there a precedent for such a thing? At that moment, is there a precedent for such a thing? Has this been done before at the university? What happens? Okay, freeze. If you're in that group, somebody's going to raise their hand, right? Somebody's going to raise their hand and say, oh, I remember how this was handled. We had something happen just like this in what? Another group. What kind of group? Maybe Campus Crusade for Christ. Maybe somebody tried to get rid of the leader of the Campus Crusade for Christ last year. And how did they handle it? Well, who would know? Somebody who was on the Campus Crusade for Christ. And check this out. If you compare the columns, looking at our two-mode matrix again, we know that there are 3 people who have some knowledge of how they handled it in Campus Crusade for Christ. That means Alice, Deb, and Glenda, right? Now, Eric is in college GOP, but he's not in the Campus Crusade for Christ, so he doesn't know about that. But there are 3 people who do. What does that mean? That you have 3 sources of information who might remember how it was handled last year in the Campus Crusade for Christ. So what does that mean? It means that the college GOP is likely to handle it the same way, right? On the other hand, if the tennis team had this situation, right, maybe the tennis team had the team captain, you know, was replaced in a late night kind of purge or something. I don't know, tennis politics, right? So, but is the college GOP going to know about that? Are they going to know about how the tennis team handled that? No. Here's why. Look, compare that second column, the tennis team membership, and the college GOP membership. There's nobody who is on the tennis team who is also on the college GOP. Nobody. So that information, that experience, that knowledge of how to do something in a group is not going to move from the tennis team to the college GOP because nobody is there to tell the story of what happened on the tennis team. So, pardon. So what that means is that if the college GOP has somebody do a leadership challenge, they're much more likely to go the way that the Campus Crusade for Christ does, and much less likely to go the way that the tennis team does. How do you represent that? You represent that by saying the college GOP and the Campus Crusade for Christ are tied more strongly to one another, right? So ideas, ways of doing things, practices are going to move across the relationship between the two groups more freely. There is no relationship, on the other hand, between the tennis team and the college GOP. Oh, look at our one-mode adjacency matrix, which talks about the relationships from groups to groups, down at the bottom. Tennis team to college GOP, tie strength of 0. College GOP to Campus Crusade for Christ, tie strength of 3. What does that mean? Number of members held in common. There are 0 members of the tennis team who are also members of the college GOP. There are 3 members of the college GOP who are also members of Campus Crusade for Christ. And so there's a 3 in that cell. What about the diagonal? Okay, the diagonal again is telling you something about the relationship between one group and itself. So when student gov has a value of 4 in the cell that relates it to student gov, it means that student gov, student government, shares 4 members with itself. But it only shares 1 member jointly with the tennis team. 1 member they have in common. That's what the tie means here. What is that member? Can you see it? It's Carl. Carl is on the student government and the tennis team. Hey, good to know. What else do we have here? Is there any other strong tie? Oh, look. College GOP and student government. 3. Who are those members? Alice and Eric and Glenda. Okay. So the college GOP knows a lot about what happens in student government. Okay. It also knows a lot about what happens in the Campus Crusade for Christ. The student government and the Campus Crusade for Christ are a little bit less familiar with each other. They only have 2 members in common. Those 2 members are, can you find them? Yeah, Alice and Glenda. Okay, so now we've gone from 2-mode affiliation matrix to 1-mode adjacency matrix. But it's a different one. It's the relationships between groups. So you want to know which groups are close to each other. You want to know which ones are far separate away from each other. Now you know. Pretty cool. All from 4 membership lists, right? You can get all this information. This is why Ron Brogger got so excited about it in 1974, and why I got excited enough to tell you about it in 2014. Well, okay. So that was, what was I getting excited about? Pretend university with only 4 clubs and 7 students, right? That's crazy. Let's get real, right? Yeah, let's get real. If you were a student in my class, you know that you have an assignment coming up in which I'm going to ask you to go out and get information about organizational membership. I want you to get it from the United States, I believe the House of Representatives. Well, I want to show you how to do that, but I'm not going to do your work for you. Instead, I'm going to go to a different kind of legislature, right? The U.S. House of Representatives is part of the U.S. Congress, which is the United States national legislature. Well, each of the states has a legislature as well that passes laws within the state. We have the Maine State Legislature here in Maine. So the website for the Maine Legislature is mainelegislature.org. And here we are. We're looking for committees. What shall we look for? There's a link right here that says committees. And let's look at some joint committees. Okay, there are a lot of committees here in the 126th Maine State Legislature, the current one, because I'm going to ask you to look at membership in 2 committees and to create a network based on those. Let's look at 2. I'm going to look at judiciary. Oh, look, here are some members. These are the members of the Judiciary Committee. Great, there's the complete list. Now, what am I going to do to create a network? I am going to use Microsoft Excel. Microsoft Excel is a software program that allows you to put information in rows and columns, just like in a matrix. So here I've started up Microsoft Excel. It is a blank spreadsheet, which is what a set of nodes and columns is. That's all it is. And I'm going to take this list here for the Judiciary Committee, and I'm just going to copy it, and I'm going to paste it. Okay. Now, when I paste it in, I've noticed a few things have happened. First is that I'll want to draw out the width of column A by hovering over the line between column A and column B, left-clicking and dragging. Yes, there we go, until we get everybody fitting on one line. And then I notice there are some rows in here that are blank. So I'm going to select a row. I'm going to right-click and hit delete to delete the empty rows. But what have I done with a cut and a paste? I have created, delete, delete. I've created a set of rows, and I also know that I have a column that I can put in. What's my column's name? Well, I'll show you in a moment. Once I'm finished here. There we go. In my first column, column B, over after my column of labels for the rows, I'm going to put in a label for my first committee, Judiciary. And what do I know? This is simple. I know in my matrix, my two-mode matrix now, that every single one of these people, these senators and representatives, is a member of the Judiciary Committee. Well, that's handy. That's convenient. Well, what can I do now? Well, I said I was going to go get another committee and get some information there. So here I am back on the web page for the Judiciary Committee. I'll go back one level to get to committees. Let's pick another one, Taxation. And there's the list of members for the Taxation Committee. I'm going to select them all, and then I'm going to head down here just below the last member from the Judiciary Committee, and I'm going to paste these in. Now, after deleting the rows, which I'm going to do just to be thorough, I'm going to ask you if there's a possible problem, and I want you to think about it while I'm deleting these rows. Why is this practice that I'm engaging in possibly a bad idea? Okay, that was the last person. So now I have a set of how many rows? Well, this is my first row, and going all the way down, I have 27 rows, right? The 27 individuals listed, right? Because we end up with row 28, and we started with row number 2. Is that true? Not exactly. We have a little problem. What if some members of the Judiciary Committee are also on the Taxation Committee? If so, then by simply cutting and pasting them in, I'll have been doing something unfortunate. I will have unfortunately been contributing to a double set of rows in which one senator or representative is going to be listed twice. So I have to check for that. Let's take a look here. Senator Ann Haskell. Is there another Haskell here? I'm looking. Oh, there's a Haskell, Anita Peavy Haskell, but that is a different person. Okay. What about Rebecca Millett? No, she's not listed above. Douglas Thomas, Adam Good, Stephen Stanley, appears to be fresh. Nathan Libby, Matthew Moonen. Oh, look, Matthew Moonen is here. Now, if I wanted to be absolutely sure, I could use the search tool for Microsoft Excel, which you get by hitting Control F. And then I could have searched for Moonen and find the first and the next, and I would keep going back and forth. So now I have Matthew W. Moonen, a representative from Portland, on 2 rows. That's a problem. So I'll delete this Matthew Moonen down below. And before I forget, I'm going to remember to put a 1 here by Matthew Moonen to let myself know and everybody else that Matthew Moonen is on both committees. Let's continue. Nathan Libby is not above. Tipping, Spitz, Knight, and Bennett. Tipping, Spitz, Knight, and Bennett are not included. Good. Marion, Jackson, and Brooks. Marion, Jackson, and Brooks are not included. So that was the one individual who was on both committees. So what do I know then? I know that these individual... Oh, am I right about Burns? See, I'm double guessing. I'm second guessing myself. I'm going to search. Is Burns occurs once? Yes, and only once. Good, 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 good. So I know that all of these individuals, never hurts to check, who are on judiciary, with the exception of Matthew Moonen, are not on taxation. And I know that the individuals who are on taxation listed below, again with the exception of Matthew Moonen, well, they were all on taxation and none of them were on the Judiciary Committee. Wonderful. Now what do I have? I have a 2-mode network. Lovely. I have the first part of my homework done. If I want to share that through a Microsoft Word file, I could copy that in, and then I could start up Microsoft Word, which all of you will have access to, either through your home or through your school student lab. And I'll type in my name at the top, always good to do just in case. And the class is always good to write in. ComSoc 375 social networks. And then I'll write in a few lines of introduction. Here is my 2-mode affiliation matrix from the Maine State Legislature. You'll be doing this from the United States House of Representatives if you're in my class. And then I'm going to insert the table. I'm going to go to Insert Table and insert a spreadsheet because it's going to be a big thing, and this is make sure that all of your information gets included. And now I can paste that information in. I already copied it here, and now I can paste it in here. Now this is awfully big, and in fact it's going to be so big that it gets put on the next page. But there's a nice magic thing that happens, which is when I click off of it, only a small portion of it shows up. It looks like that's a problem, but turns out if you double click on it again, the entire spreadsheet with all the information in it is brought back. You just click off it to make it go away again. Not so bad. So, well, the next thing to do is to say, here is my first 1-mode adjacency matrix. Connecting people with people, or a people by people matrix. Then I need to put that in. Oh, but I need to create it now, don't I? Well, let's head back to Excel. Okay, so I have 27 people in this. Oh, actually 26, right? 26 people. I'm going to create a 26 by 26, 26 rows, 26 column matrix over here. I'm going to teach you a trick. How do I make all those names show up as columns as well? I can head over to paste and hit with a little arrow and find paste special and hit values transpose, and it will flip those the row labels and make them comma labels when I paste it in that special way. Oh, there they are. So if I want to make sure that all the labels show up, I can make them a bit wider. There we are. So now I can go through and check. And now what do I know? How can I make this go a little bit quickly? Well, one thing I know is that all the folks who are on the Judiciary Committee, which is everyone right through Wayne Mitchell, is going to have how many committee memberships with other members of the Judiciary Committee in common? 1. So Senator Linda Valentino, right, is going to have 1 in common with Senator Linda Valentino. Senator Linda Valentino is going to have 1 in common with John Tuttle, right, and so on and so forth. I'm going to copy and paste that one over here. I don't know why it was a hyperlink. And who is that through? All the way through Wayne Mitchell of the Penobscot Nation. Okay, so I'm going to look for Wayne Mitchell of the Penobscot Nation, and I'm going to remind myself that everybody up to that point, there's Representative Wayne Mitchell, has a tie of 1 with Senator Linda Valentino. Now, I know that everyone afterwards, Senator Linda Valentino is going to have a connection of 0 with. Why? Because they're on the other committee that she's not a member of. Whoops. Right, all the way through Representative Brooks of Winterport. Now, who else is like Senator Linda Valentino? Why, almost everybody else who is on the Judiciary Committee. I say almost because we have an oddball, one oddball, Matthew Moonen, and we'll get back to him. But for everybody else, if I just take that row of information and I say I'm going to copy it, that row, it's the same pattern is going to apply. Control C for copy. It's going to apply for everybody else who's also on the Judiciary Committee, which is everybody all the way down through Wayne Mitchell, except for our oddball, Matthew Moonen. So I'm going to head over here and watch. If I paste, when I paste, I have everybody else in that row get the same information as Linda Valentino did. So Representative Deschamps gets the same treatment. Kimberly Monahan-Derrick gets the same treatment. Why? Because they're in the same position. They're sharing the common membership with the same people. What about Matthew Moonen? Oh, he's a trick, right? He's different. So we'll get back to him later. But Stephen Moriarty is of the same ilk. Lisa Renee Villa, Jared Crockett, and so on until we get down to Representative Wayne Mitchell. I've completed half of my network already for this one-mode matrix. Now, what about Senator Ann Haskell? Who is she? What does she do? Oh, here she is over here. Well, we know from our two-mode matrix that she is on the taxation committee. Who does she share taxation with? She shares that with all the other members, which is all these other people here, starting with herself, Ann Haskell, and nobody else before that. So let's go up and let's find out what column Ann Haskell is in. Okay, we know she's in row 16. Where does Ann Haskell start? Ann Haskell starts in column V. So we know that at that point for column V, all the way over to the right with everybody else, she's sharing one committee, the taxation committee. And we know with almost everybody else that came before her, who's on the Judiciary Committee, that she does not share membership with them. Now, I said almost because who's our oddball? Again? Matthew Moonen. Here's Matthew Moonen. We have to remember that Matthew Moonen, who is in column N, actually shares a 1 here. Matthew Moonen does share judiciary membership with Ann Haskell. So now, the situation that Ann Haskell is in, where she shares a membership of 1 with Matthew Moonen, with nobody else, 0s with everybody else on the judiciary, and a 1 with everyone else on taxation. Who else does she share that pattern with? Well, everybody else, other than Matthew Moonen, who is on the taxation committee. So if I take Ann Haskell's row, and I copy it, I can paste it in for everyone else on the taxation committee. Because, for instance, Representative Jackson, Roger Jackson of Oxford, shares a committee with, who is this in column N? Matt Moonen. Right? And also with everyone else, starting with who? Ann Haskell, and continuing on all the way across for all these other members of the taxation committee. And if we went up to the top, we could look up their names, including Joseph Brooks and others. So we can take that information, and for everyone else on the entire taxation committee, except Matt Moonen, our oddball, we can copy and paste that in. Now, we have that one row left. We have to think about Matthew Moonen. What are his overlaps? Let's take a look. So here he is. He has a 1 for what? For the... Let's make these smaller. I'm selecting all the rows and I'm making them not so tall. There we go. There's Matthew Moonen. He has 1s for judiciary and taxation, which means he shares 1 committee with everyone on the judiciary. He shares 1 committee with everyone on taxation. And he shares 2 committees with everyone who is on both judiciary and taxation. Well, who is the everybody who's on both judiciary and taxation? Matthew Moonen himself. So, for Matthew Moonen of Portland, we're going to expect to see ones for everybody except Matt Moonen, because he shares 2 committees with himself. He shares 1 committee with everybody else in this matrix. What kind of matrix is it? It is a one-mode matrix because the columns and the rows are the same. And it is a persons by persons matrix, talking about the shared committees between people. Now, if I just take that and I copy all the rows and columns, hit Control-C after I've selected them all, head back over to Microsoft Word. I already have the space where I say, here's my first one-mode adjacency matrix connecting people with people. I will insert the table as an Excel spreadsheet. And I'm going to paste that in. There it is. And if I click off, it's going to appear. It's going to look like not all the data is there. Right? Where did all the other columns go? Well, if I double click on it, all that data will appear again. There. All the columns and rows. Which means that your instructor, that's me, will be able to see it as well. And if I click off it, it goes back into a dormant state. And then I can type in my next line. Here is my second one-mode matrix showing the group by group adjacency matrix relations between 2 committees. You'll want to write something like that. And then, goodness gracious, do we have to repeat that big matrix all over again? No, we don't, not at all. We'll just want to create a much smaller matrix, committee by committee. Well, how many committees are there? There are 2, Judiciary and Taxation. Judiciary and Taxation. Now, we have only 4 cells to enter. This is a much easier network to describe. Okay. How many people are in both Judiciary and Taxation? 1. Representative Matthew Moonen, who is in both Judiciary and Taxation. So we'll put a 1 there. How many are in both Taxation and Judiciary? 1. Now, how many are in Judiciary and Judiciary? Well, we could do 2 things. We could count the rows in which there are 1s for Judiciary. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 14. See, now, but we could make mistakes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14. 14. We could do that. So we know there are 14 people who are in both Judiciary and Judiciary Committee. Or we could say the Judiciary Committee has 14 members. We could also go down to the bottom of these rows, and we could say, let's create an equation, an equal sign, and let's make it the sum of what? A sum is adding up a bunch of these cells. Which ones? Well, starting with B2 and going all the way to B27. And it will give us a total, because the zeros won't count, only the ones will. How many ones are there? 14. We could do the same for C. We could say how many ones are there? If we add up all these, the zeros won't count. What is the sum from C2 to C? 27? 13. We could verify that by doing a personal count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, Matt Moonen. Okay, the 13 goes here. 13 people who are members of taxation, who are also members of taxation. And there's our 2 by 2, meaning 2 rows, 2 columns, matrix. It's a one-mode matrix. And if we insert a spreadsheet, boom, there it is. And I have done my work. Now, the only difference that you have in your work is that I've asked you to collect that information for what? Well, let's take a look. I believe it is for the U.S. House of Representatives. So where would we find that? Well, we could go to Google. Well, now we need to find that committee information. We could type in U.S. House of Representatives. And there it is, house.gov. Okay, we don't want to find out about the Capitol Dome Restoration Project, although that's very nice. I think we're looking for, oh look, committees. Here are a bunch of committees, just as with the Maine State Legislature. They have some different names. And now some of them are going to have large numbers of people on them, and some of them are going to have small numbers of people on them. If you look at the Agriculture Committee, for instance, we click on that. Oh, where's the members? Oh dear. Well, let's try about. Committee members. There we go. How many people are there? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46. Wow, that's a lot of members. Other committees will be much smaller. Rules Committee. Where do we find the members? Let's try about again. Committee members. There we go. How many members are there? Okay, let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. A much smaller number. You may want to pick relatively small committees. If you're feeling ambitious, you could pick relatively large ones. Pick 2. And for those 2 committees, I'd like you to generate a 2-mode matrix describing membership of individuals with these groups called committees. Then I'd like you to create 2 1-mode matrices. Do it using the practices that I've shown you today in this walkthrough, and you should be just fine. Best of luck, and if you end up having any troubles, know that first of all, you should start a little bit ahead of time, anticipating that you might run into trouble. And if you don't, then that's great. But if you do, you could do what? Get in touch with me. Send me an email to james.m.cook@maine.edu or give me a call. Area code 207-621-3190. I look forward to seeing your work, and I wish you the best of luck in getting it done. Okay. Thanks very much for your time, and good luck with your homework.